Hello students, today we are going to learn about how to install a microvision tool on your desktop. So first of all you have to go to the Google, write down kill microvision 5 and plus 8051. So here is the first link that you will be looking at. It will lead to you to the kill company and it's C51 compiler. So here you can see that most of the compilers are available and we are looking for the evaluation software. So this software you can use for the educational purpose as well as for teaching purpose. You can download it by clicking on this link. It is hardly a 95 MB. So you have to give some of your details like what is your first name, what is your last name, email ID, and the company you are working with, and your country name and all those things. So once you send this, you will get a download link. Now you don't have to do all these things. If you want to download a previous version, I have already put the link within the description. From there also you can download it. So once you have downloaded it, you can start your program in Microvision IDE. So I'll close this. So go to start menu, find out for KEIL. So it is kill microvision 5 compiler is available. Click on this. So to start the project, what we have to do is we have to go to projects. After that projects, we have to choose a new microvision project. Click on this and it will ask you a name of the project. So you have to name something. So I'll name it as a, let us say, assignment 1, or I can give an example 1. Okay, it's just name of your project and save it. After saving it, it will ask the device that you want to develop a C code for. Now in our case, it is 8051. So 8051 manufactured by many companies, but we are going to focus it on Atmel company. So if you search it, also here what we have is Atmel company. Click on this plus sign. So there are many derivatives of 8051. Those are available. Right now we are interested in 89C51, 8089C51. So this is the derivative that we are looking for. Click on OK. Then the next window will pop up and it will say that startup.a51 should be included in your folder or not. So press no to this. So once you have done, your project is now ready. Now what you have to do is we have to make some files under this source group 1. So we will click on new file. From this we can create a new program. I will click on this. So this is a text file. So we have to write down a code over here. So I'll copy paste my code from assignment number 1. Okay, so this was my code. So I'll copy this code and I will paste it in a microvision file. So if you look at this code is total in a white and black. Why? Because it is in a text file. So what we have to do is we have to convert this file into a C program. To do that, what we have to do is we have to go to the file menu. From file menu, we have to go to the save as option. So click on save as and we have to name this. So I'll name it a bit different because we have already have an assignment number 1 over here. So I'll name it as ASSIMENT underscore example number 1. Now why I am giving this extension, because I have already a file named like this. So I'll say save. The name could be anything, and after that we have to put .c extension. So the compiler now understand that this is not a text file, it is a C program. Now when I say save, you can look at this text. Now this text is changed into different colors. So the variable's name will be in a blue color, let us say, in and include files will be in a light yellow color. So this has to be happen. It means that it is a C program. Right now here also you can see that it has come with a .c extension. Now the next thing is that we have to include this file into our project. Now to do that, what we have to do is we have to right click on the source group 1 and we have to choose option add existing files to source group 1. So click on this and it will give you the list of all the files. Now we have to search for our file, and my file is assignment underscore ex.1. We have to select this file and we have to click on add and close it. Now here you can see that there is a plus sign. If you click on this plus sign, so here you can see that your .c file has been added to your project. Now the next thing that you have to do is, as I told you, this is a C code, and this C code will be converted into assembly language code. Now to do that, what we have to do is we have to compile this program. Now to compile this program, we have two options. One is build. By pressing F7 also you can do this, and the next thing is called as a rebuild. You can choose any one option. So I will go with the build option because my program is very simple. I will click on this. Once you click on this, at the bottom you can see that it shows if there are any errors. So in my example, it shows 0 errors and 0 warning. So once you get a 0 errors and the 0 warnings, you are ready to simulate this program. So next step is to simulate this program in 8051C kill compiler. Now to simulate this program, we have to go with the debug menu. So from the debug menu, we have to choose the option that is start stop debug session. So I'll click on this. So once you go into this, there is one more warning. So it says that it's the evaluation mode. As you know that while downloading this, it was told that it will be an evaluation mode and it can run the code up to 2 kilobytes, not more than that. So it is fine for us. Click on OK and it will go to the debug window. Now, let us run this program. While running this program, we'll get some of the indicators. These indicators will tell you which line is running. Now to run this program, we have various options like a step-by-step running or a continuous mode. Okay. So if you want to run the program step-by-step, the option is over here and it says that it is step over. So we have to choose this option if you want to run this program in a step-by-step manner. So if I click on this, as you can see that, okay, so it is running in a step-by-step mode, and here you can see that in the bottom the variable z is changing its value. Now I want to observe port 1. Now to observe port 1, what I have to do is I have to go to the peripherals and IO ports, and from the IO ports I have to choose port 1. Now in many applications you require to observe serial ports, or maybe in some examples you want to observe the timers. So that can be chosen from this peripheral option. So right now I'm interested in port 1, so I'll choose a port 1. You can add a multiple ports, like if I want to add port number 0, I can add port number 0, and you can have few more ports. Right now I'm only interested in port 1, so I'll close this. So once you've done this, you can click on step-by-step mode. So here you can see that it works like a binary counter. At any of the point, right, say that you want to reset this program. So there is one more option to reset this program, is called as a reset. So right now I'm going to reset this program so that you can observe what happens. So I'll press on reset. Okay, and here you can see that the compiler has developed your project. So I'll in assembly language. So I'll run this stepwise, and you can observe the values on port 1 as well as in the program as well as within the assembly code that the compiler has developed. So I'll click on this. You can see that over here it has assembled your program. So let us click on to the next step. To the next step. Now here the value of z is 0 and it has passed to the port 1. Now when I click on to the next, it becomes 1. When I click on the next, it becomes 2. Same time you can observe your C program, at the same time you can observe your assembly language program. So in the assembly language program, as you can see that there is increment function. Of course we cannot understand what is the logic behind this program, but yes, whatever the C code is there, that has been converted into an assembly language code. So I'll go on clicking on this and you can see that how it works. Now sometimes if your program is really lengthy and you want to run this in a continuous mode, there is one more option over here. So if you click on this option, run, it will run your program in a continuous manner. So if I click on this, I no more need to click again and again. So it is running in a continuous mode. But in the continuous mode, you cannot observe these values because it's pretty fast. Now to stop this program, we need to click on this red sign, and this is to stop the program at any moment. So I'll stop this program, but it is still running. Now to stop this, what we have to do is we have to go with the reset. So once I will go to the reset, the program is reset, CPU is reset, and you can see over here that your port has been reset and all the values are becoming 1. As you know that when I reset 8051 microcontroller, all the ports are output port and the pins will be high. So this is the one function by which you can observe the port. Now let us go to one more function which says a logic analyzer. If I click on this, there is one more facility. It's called as a logic analyzer. So click on this. I can observe the ports by evaluating this, and this is a graphical tool actually. So I'll make it a little bit bigger so that you can observe what is going on. So go to the setup, and here what we have to declare is which port you want to observe. You can observe a port or you can observe a simple port line. So I'll add the port. So here we have to insert new, click on this, and I want to observe port 1, so I'll write down P and 1. So P should be in a capital. Okay, so whatever the SFR or the special function registers are there, those are all written in a capital letters. So once I have written, press down close. So here you can see that we are going to observe port number 1. Now as you know that this is a counter and which is going from 0 to 255. So once it reaches to 255, the counter will reset to 0. So ultimately what we are going to look at is a sawtooth wave. So let us run it step by step. So you can observe over here, slowly the waveform will be raised. I will make it a little bit bigger. So here you can see that the waveform is rising and it's trying to achieve its value to 255. So let us run it continuously because it will take a long time. So if I run it continuously, you can see over here I'll get a sawtooth waveform. At any point of time you can stop this program and you can observe the waveform. Even you can have a zoom in so that you can observe it very closely. We can have a zoom out. Okay, and even we can observe what is the value at the particular point. So here you can see that the value of 153 is available. Now here if I click, the value is 242 is available, and if I click on the top, you can see that the value of 255 is available. So this is how we can develop the program, and even we can simulate a particular program. After doing this, let us say you want to modify your program, but you cannot modify the program in the debug mode. What we have to do is we have to stop this debug session. So go to the debug and stop the debug session. Once you stop the debug session, now you are ready to modify the program. After each modification, you need to compile the program so that the compiler will convert your C program into an assembly language program. So whenever you are making some changes, you have to compile the program, and then only the changes will be reflect in your debug window. So for this now we'll stop over here. We'll continue in the next tutorial.